Welcome back. And in the last video, we're at the point where we assume that the data is we have the data, we have replaced missing values, we kind of prepared the data by bringing feature variables to similar numerical ranges and encode category features. So we are good to go. But there's another thing, because if we now take all the data that we have and estimate a model, then we are not going able to evaluate if our model also is able, for instance, to generate predictions for new and unseen data. So that is why we usually at least split the data into, for instance, a training and a test data set. Then what should be noted here is that all we said in the last video is usually done based on the information in the training data set. Okay, so if we, for instance, standardize the feature variables, we only use the, for instance, average value and the standard deviation from the training data in order to bring the training and the test data to, for instance, a standardized numerical range. Okay, but usually, so the bottom of the most important aspect here is that we split the data into training and into test data because we want to have some data which hasn't been used for training a model and which then can be used to evaluate if our model is able to generate good predictions for new and unseen data. So for splitting the data, there are also some nice functions available in the sklearn package. So you can see here we have from the model selection the train test split function. And if we have a data set which is artificially generated here and only consists of 10 or like 5 pairs of feature variables, so we have 2 feature variables which are given here. And then we would have the corresponding target values. So as you can see, it's not a real data set, it's just some values which are very unlikely that we observe such values in reality. But that's not the point here. The point here is we can now split the data by using the train and test split function. And what we need to specify is the fraction of data points that we want to have for the test data. And the remaining fraction obviously is going to be the fraction that is used for the training size. And then we can give here a so-called random state, which makes sure that because what's done here when we use the train test split function is that randomly some of the values are drawn and used for training data and some of the values are drawn and used for test data in the fraction that is specified here. And if we want to be able to reproduce this random splitting, then we can set a random state here. Okay, so for instance, if we do it like this, as you can see, it will always give pairs of training and test data. Then you can see what happens here, for instance, with the random state of 42. Then it will take this observation for training data, it will take this row for training data, and it will take this row for training data, which you can see here. And you can see that the corresponding target values are also taken. And the remaining values are going to be taken for test data. It also has I think it has a shuffle method, or like a possibility to say to this function that it should randomly shuffle the data before it draws the data. So that is when we have it like this. But when we set shuffle to false, then you will see that it really doesn't shuffles the data, but it splits the data in its in the way how the data is ordered. So if we have like 2/3 of the whole data set that we want to use for training, it uses here the first 3 rows of our 5 rows that we have here for training data, and the remaining is used for test data. And sometimes you may need this, especially when you may not want to have the data to be randomly shuffled in order to use them for training and testing. Okay, so but if you do not specify anything specific here, then by default it shuffles. But if you want to have the same splitting of the data again and again, then you can set the random seed, which is probably okay. What was the name of this? Sorry, it's the random state. Okay, sorry. Okay, so this is how you may be able to split the data into training and test data. Sometimes that's enough, but sometimes we need to split the data one more time, or let's say it like this: if we do this for one time and observe really good results, what could happen in theory is that maybe by the randomness, that in the way how we splitted the data here, we got lucky and generated a certain splitting which produces a performance that is better than it would be in reality. I hope this kind of makes sense to you. And in order to make sure that the maybe good results of our model do not really depend on the randomness that is given here by splitting the data, we may want to do this more often and again do the same thing. So we may want to split the data for 5 times with different and generate different sets of training and test data. And for each set of training and test data, we may want to predict. We may estimate a model and generate predictions, evaluate the predictions, and then, for instance, we could do this 5 times. And if for these 5 times we again and again get good results, then we have probably a better feeling towards the randomness in splitting the data when it comes to training the model. This can be done in different ways, and the most popular way I would say is the so-called k-fold cross-validation. So what I've been describing right now is cross-validation, and what it does, it splits the data into equal sizes. So if we have a 5-fold cross-validation, it splits the data into 5 equal-sized parts, and then, for instance, uses 4 of these parts in order to train the data, and the remaining fraction is used for testing. But then this is done 5 times and shuffling around those 5 equally sized parts. This is also implemented in sklearn and can be done also quite easily. Herefore, you need the k-fold class. Here you can set the amount of splits that you want to have. And what it basically does, it shuffles the data 5, or it doesn't shuffle here if you do not want to. By default, it just uses the sequential ordering in the data. But what it does, it gives you the information which indexed of the index values that you need to use in order to generate different training and test data sets. So if we do this for our data set that we had before, so here we have the first feature variable, we have the second feature variable, and here we have that was already the first split, so let me just quickly show you what I'm referring to. So from our example before, our data set in raw format would look like this. So we would have here the first feature variable, we have here the second feature variable, and here we have the target values. Yep, but still not 100% correct. Now it should be fine. Okay, so now you have the whole data set. Okay, this is how the whole data set looks like, including feature variables as well as target variables. And then if we use the k-fold method, what it does, it splits the data 5 times in different ways in order to create different versions of training and test data. And as you can see here, in the first split, it uses the last 4 observations for training data and the first observation or the first sample for test data. Then for the next split, it uses all the data except for the second row for training, which is here given for testing. In the third split, it uses all the data except for the third row here. I mean, it doesn't necessarily relate to the number of the rows, because here we have 5 rows in our data set, and we have 5 splits. But for instance, if we would have 10 data points and 5 splits, then it would exclude, for instance, in the first split, the first 2 observations, which are going to use for test, and the remaining is used for training. In the second split, it will use the third and fourth for testing, and the remaining for training, and so on and so on. Okay, and usually the common procedure here would be this: to for each split we do the same thing. So we estimate a model, we evaluate its predictions, and record its performance, and then we will take a look at the average performance of all the splits in order to make sure that the performance of our model is not related to some certain random splitting in the data here. Okay, that's like what's very common and popular, so you need to know it. Furthermore, what you should be aware of, that usually it doesn't is not enough to only take a look at training and test data, because especially for more advanced models there will be something which is called a hyperparameter, or more hyperparameters. So far you did not hear about it, but it's a hyperparameter in a very general way is something which also needs to be specified in order to calibrate the model. But in comparison to the parameters, it is not specified or calibrated during the estimation process. So at the moment, what you can imagine is you can think about if you want to include, for instance, all feature variables in order to make your model, or the hyperparameter could be that you pick a certain number of feature variables that you are going to use for your model. And so the point here is not at the moment what a hyperparameter is. The point here is that usually then you need to do also something which is called hyperparameter tuning. So that just means what you usually do is you will have your training data. You will use the training data for calibrating the model parameters. Then you will have a validation data set that you are going to take a look at how its performance is altered or is affected by certain changes of the hyperparameters that you are going to specify before you are estimating the model parameters with the training data. And again, in order to make sure that there is some data, unseen data, which we are going to evaluate with our already specified model with specified hyperparameters and trained model parameters, we will have a testing data. Okay, but this sounds more complex right now, and it is in reality. In reality, what we are going to do is we will split the data into, you can say, like in a training and hyperparameter validation data set, which you can, for instance, in the moment, can think about it as one data set and then save some testing data. And with this training and hyperparameter data set, for instance, we can do cross-validation as before, and evaluate very good hyperparameters and tune the hyperparameters and calibrate the best possible estimates for the parameters of the model. You will see about that and learn about that during the course using the examples that we are going to use. But still, at this point, it's important that you already heard about it, that there is something which is called hyperparameters, which typically is not directed, which is not directly estimated in the estimation process, but this is something that needs to be set by you as the user. And as it is a choice, you may want to take a look and evaluate how this choice is going to affect the performance of your model. And in order to evaluate this, we will simply take a few more data points that we will not use for testing data. So I think only there needs to be said one more thing when it comes to splitting the data, which is quite an important topic, because in many examples you will find, especially those that are not related to, for instance, to the area of finance or to the area of economics, you will see that when splitting the data, this is really done usually randomly. Okay, so the original ordering of the data set is not kept, and the data is somewhat shuffled, and split it. That is not uncritical from a perspective of someone from the financial area, because in financial applications or in economics in general, we often and very often do have systematic patterns over time, meaning that we have some form of dependence. So for instance, for an economy, there are some times, for instance, on stock markets, which are described as a bull market. So there is a market phase where usually the whole market performs. So that means like more or less all companies perform slightly better than on average systematically. And then there's something like a bear market phase, which is the opposite. So there is some systematic movement over time. And if you have a data set which includes, for instance, like a whole economic cycle with, for instance, a bull and a bear phase as well, then this pattern is in your data. And now if you randomly split the data, this can cause problems for the estimation of the parameters of your model. The only thing which makes it still good for your model is, or which would make it, in my opinion, kind of less critical if you want to randomly split the data, is that if you wanna, you need variables which are able to keep the systematic behavior over time in the data. Okay, so for instance, when it comes to stock markets, the VIX, so the volatility index, is something that is popular in capturing the systematic state of the stock market. So if you include something like this in your data, then it's okay, because we approximately may get something which is called conditional independence. So conditionally on the information of the economic state and of the company-specific variables, then we have something like independence between the observations for each company at each day. So if we have something like this in the data, then the random splitting is in the data is, I would say, less critical from a statistical point of view. But if you have this kind of systematic behavior in your data and you do not have any variables in your data set which account for the systematic behavior, the random splitting can really cause problems. So for instance, if you then have it in your training data set where you have only observations from like a bull market phase, and then you will estimate your model, and then you will make predictions for the bear market phase, this can be different and cause problems for your model, because things may behave differently during these different kind of economic states. Okay, sounds even maybe a little bit complex right now, but bottom line is here, just be a little bit aware of dependencies within your data when it comes to randomly splitting the data. And in general, when you want to randomly split the data, you should have variables that account for systematic patterns, so systematic dependencies in your data set. All right. So in the next video, we want to take a look at now if we have already estimated our model, and especially for the testing data, how do we want to evaluate its performance? And see you in the next video. Bye bye.